Hey guys, Mr. Middleton here. Today we're going to talk about standard form. This is the third form, linear form that we talked about up to this point. Okay, after watching this video, you should be able to transform linear equations to standard form and from standard form to slope-intercept form. You should also be able to use x-intercept and y-intercept to graph a line in standard form. Okay, standard form of a linear equation is ax plus by equals c. Notice where our x and y in relation to the equal sign, they're on the same side now. Okay, in standard form they're on the same side, and they were on different sides or opposite sides in slope-intercept form. I also want you to see that there's no m in this equation. There's no m in this equation. And so you cannot look at this question, or let's look at this equation and find slope. Can't just look at it and find slope if it's in standard form. Okay, so first things first, we need to make sure that we're still able to find slope from standard form. This is how you find slope. You get y by itself. Okay, and so what that means, we will subtract 6x for y equals 20 minus 6x, and then divide by 4. Okay, now the only thing that really matters is here, because that's what the question is asking us. So we have negative 6 divided by 4. 6 over 4, we'll simplify that and get negative 3 halves. Okay. Same thing here. Subtract x from both sides. 3y equals a negative x plus 12. Divide by 3. And so focus here. And that will give us negative 1/3 x. And then lastly, I'm going to get y by itself in this case. So I'm going to add y to both sides. I have 2x equals y plus 7. I'm going to subtract 7. And so I have y equals 2x minus 7. Okay, you'll notice that in all these problems, I'm basically just putting it in slope-intercept form. And the slope is the number in front of x. Oops, and I messed up. Do not include x as part of your slope, please. Okay. Alright. So, there we have it. So, if standard form is not helpful in finding slope, what is it good for? This equation is good for finding the x-intercept and y-intercepts. Okay, we've talked about and used the y-intercept. So with that info, what is the x-intercept? Okay, a y-intercept always has a coordinate of 0 something. I'll just say y here. But an x-intercept has a coordinate of x, 0, where y is always 0. Okay, so where we found the y-intercept on the y-axis, we always found it somewhere here. The x-intercept we'll always find on the x-axis, somewhere here. Okay, on this line here. Y-axis on this line. Okay, now standard form is very equipped to find these intercepts. In the same way that when we plug in x and y into slope-intercept form, it made the equation true, it helps us even more to plug in x and y in standard form to find the intercepts. Because we just pointed out that when we have a y-intercept, x is 0. When we have an x-intercept, y is 0. And so we use that to our advantage to find x and y intercepts. using standard form. Because if I'm asked to find the x-intercept, what I'm going to do is say, okay, the x-intercept happens when y is 0. So, in this equation, I'm going to plug 0 in for y. What's 9 times 0? It's 0. So essentially, it goes away. And then I can say, okay, well, I know that y has to be 0 in every x-intercept. What would x have to be in this situation? And then I solve. And when I do, I find out 9. Okay, and so the x-intercept would actually be at 9, 0. And I can do the same thing with the y-intercept, because I know that x will be 0 when we have a y-intercept, so I plug 0 in. 4 times 0 is 0, goes away. And I have 9y equals 36. Divide by 9, y will be 4. And so that intercept will be at 0, 4. So you see that we plugged in 0 for x to find the y-intercept and 0 for y to find the x-intercept. Okay, now that's a mathematical reason that you can do that. The way I like to teach it is the cover-up method. Okay, now pay attention to it, so because there are a couple things that you can mess up on, but it's just as simple. Cover-up method to me, or to anybody, when you're trying to find the x-intercept, what you do is you cover up the y, and that's just like substituting 0 in for y, right, because it disappears either way. And so what we have is 5x equals negative 60. You see how I covered that up? Covered up the y, I rewrote the equation. And now I solve for x. Divide by 5, divide by 5, x will equal negative 12. And so my x-intercepts at negative 12, or at negative 12, 0. And I can do the same thing with y. Now, here's the tricky part. Like I said, there was going to be one. Do not cover up the sign in front of the second variable. It's very important. Okay, if you cover up and just say, I'm covering up everything, well, that makes it look like it's positive 4y. But it's not. Remember, the sign goes with that number right behind it. So I have negative 4y equals negative 60. I'll divide by negative 4 so I can solve. And so then I have y equals 15. So my y-intercept is at 0, 15. Same thing here. Cover up the y, so I have 3x equals 9. Divide by 3. X is 3. 3 is 0. Do the same thing here, not covering up the sign because now it's negative y. I'll divide by negative 1, and y equals 9. And that's 0, 9. Okay? So we see how that goes. Flipping to the back side then, because we can find the x and y intercepts, and sometimes that's all they ask us for, but sometimes we'll have to graph using the intercepts. Okay, so what we'll do is find the x and y intercepts just as we did in this last section. Plot each point on the graph, the x and the y intercept both, and then draw your line. So for this problem, we have 6x plus 2y equals 12. This is in standard form. We can tell because x and y are on the same side. And so we're going to find the x-intercept, covering that up. 6x equals 12. Okay. Divide by 6. X equals 2. The x-intercept's at 2. Remember, that means that the point is 2, 0. I'm going to do the same thing for the y-intercept. Cover up the 6x. I have 2y equals 12. So 2y equals 12. Divide by 2 to get y all the way by itself. Y equals 6. Or 0, 6. Okay, so I found the x-intercept, the y-intercept as we did last time. And now we just plot our points. Point at 2, a point at 1, 2, 3, 4, 5, 6. And those are our 2 points that we found, our x and our y-intercept. And the line just has to go through those 2 points. Or we just have to draw the line through those 2 points. Remember, it goes through a bunch of points. Okay. All right. Try the second example on your own and bring it to me. I'll be checking that with your notes. Okay. Let's look at number 4. We're going to be putting a line into standard form. Okay. Now, here's the rule with standard form. A, B, and C cannot be fractions. And I say that and say, oh, well, then I'll use decimals or decimals. A, B, and C cannot be fractions or decimals. Okay, so when putting an equation into standard form, you must have whole numbers. Or integers. Integers, that's what I should have said. Integers is a better word. All right, so remember that the big difference that we noticed right away was that, hey, x and y are on the same side here. So that's essentially what we're going to try to do. We're going to try to make sure that we get x and y on the same side. For this first problem, it's pretty simple. We're going to add 4x to both sides. So on the left side, we have 4x plus y equals 7. That's standard form. Okay. For the second problem, we still want to get x and y on the same side. I'll subtract 2/3 x from both sides. Remember that those aren't like terms, so it's not like I can just say put these together in any kind of way. So I have negative 2/3 x, y is positive, plus y equals 4. Now remember what I said, that A, B, and C cannot be fractions or decimals. And so I need to find a way to get rid of this. The best way to do it is to find the denominator, or the least common multiple of the denominators, and multiply. So in this case, our denominator is 3. I'm going to multiply both sides by 3. Both sides of the equation by 3. Negative 2/3 times 3, remember when I do that, it cancels out. That's the reason I picked 3. So I have negative 2x plus 3y equals 12. And so you see, even though we started off with a fraction, now we have this problem in standard form without fractions or decimals. Okay, for number 3, we'll do the same thing. I need to make sure that it's in standard form. That means x and y are going to be on the same side. So I'll add 1/5 x to both sides. And so I have 1/5 x plus y equals negative 9. And again, I have this fraction. I need to get rid of it. I'm going to multiply both sides by the denominator here. Times 5 times 5. And so I have just 1x, or x, plus 5y equals negative 45. And so you see we've changed that to standard form and made sure that we didn't have fractions or decimals there. Okay, so let's pull it all together here in this last section. They want us to find the slope, x-intercept, and y-intercept of 2x minus 4y equals 28. Okay, what form is this in? It's in standard form. As we talked about today, standard form is great for finding the x and y-intercept. So let's just do that since it's already there. So we have 2x equals 28. We're going to solve for x, and x will give us 14. So we know that our x-intercept's at 14. Remember that that coordinate would be 14, 0. Okay, I'm going to cover up the x and rewrite my equation and solve for my y coordinate, or y-intercept, sorry. Divide both sides by negative 4, and y will equal negative 7. Okay, remember that points at 0, -7. Alright, now it's asking us to find the slope. Remember, for slope, we're basically putting it in slope-intercept form. And so that means I'm trying to get y by itself. How can I do that? Well, I'm going to subtract 2x from both sides. And I have -4y equals -2x plus 28. And then, to get y all the way by itself, I'm going to divide by -4, both sides. And so I have -2 divided by -4, x minus 7. Remember, negative divided by negative is positive. 2 over 4 is 1/2, so I have 1/2 x minus 7. So what's my slope? Because that's what they really asked me for. My slope is 1/2. Okay. What form is good for finding slope? Well, we just had to move it into slope-intercept form. Slope-intercept form is the best for finding slope. Thus, slope is in its name. Which form is good for finding the x-intercept? Standard. Standard form is probably way better than slope-intercept form to find it because it's just set up for it. Which form is good for finding the y-intercept? And actually, for this, both work. Both work equally well. Okay, remember in slope-intercept form, our y-intercept is already given to us. It's written inside the form. And in standard form, finding the y-intercept is just as easy as finding the x-intercept. Okay, so there we have it. Some practice with standard form, writing it, changing it to slope-intercept form, changing it from slope-intercept form to standard form, graphing it, all those things. Remember to complete this example for me. See ya.